but thanks for playing.
Yeah, you're welcome.
Cutoff. Cutoff is used to differentiate between what and what. What are you talking about cutoff? What the heck is cutoff? Alright, well let's see. Maybe y'all can brute force this one. Is it A, the sampling length used in calculating roughness? B, the direction of the machine marks? C, the maximum roughness? We've already said that's not it. And is it the minimum roughness? What do you call the direction of the machine marks? What do you call this? Got this sample like this, and the machine's been made the marks in this direction. What do you call this? Different ways of specifying this. You might ask for one of these that looks perpendicular. You might ask for one that's centric like this. Huh? This is called the lay. That's the lay. That's not what the answer is to this. All right, let's see. We talked about the difference between what's going on here, this roughness, and this sort of general overall pattern, right? How do you differentiate between the two? How do you filter for this?
You tell it to take short measurements.
All right, so you're saying you change the length.
The cutoff is.
The length of the measurement is what you're saying. All right. So let me read this question again. The concept of cutoff refers to what? A, the sampling length used in calculating roughness. B, the direction of the machine marks. C, the max roughness, or D, the min roughness.
We're going with A on this one.
All right, let's go with A. Yes, good answer. Good answer. When specifying roughness, units for RA are given in what? Microns, or micrometers, micro inches, or 1/1,000,000 of an inch. Either A or B can be used, depends on the units used on the drawing. Or D, radians.
I'm going to go with C.
C, good. It is permissible, or is it permissible, to specify the process that is to be used to achieve the desired surface finish?
True.
Yeah, it is. That's one of the rare times where you would actually call out a manufacturing process on an engineering level. Usually that's
What did you just say?
I don't remember. Me either. What do you mean what was the question?
Yeah.
Is it permissible to specify the process that is used to achieve a desired surface finish? Yes. It is done above the surface finish symbol. Don't be lulled into other answers. What is the relationship between roughness and waviness? A, they are the same thing. B, waviness is smaller. That is, it has a shorter wavelength than roughness. C, waviness is larger, has a longer wavelength than roughness. D, waviness is the shape, that is the wave form of the roughness, sort of like the timber of a wave.
I'm going to go with C.
Yes, I would go with C. Which of the following is an example of a discrete fastener? I bet you could come up with some of those. Number 20, integral fasteners are built into the workpiece. Which of the following integral fastening methods uses an elastic deformation to keep components together? Clinching, that is a toggle lock. B, staking. C, snap fit joints. Or D, all the above.
Hey.
Let's see, toggle lock. Y'all remember what toggle locking looks like? Yeah, a little punch fastener. Let's see. Maybe if we misspell it badly enough. There we go. That's it. Google knows better. Now, let's talk about that.
This is the last thing.
Think back to our, I'm not giving you the answer just yet. The question goes. Which of the following integral fasteners uses elastic deformation to keep the components together?
It's the last one.
Well, there is elastic deformation there, but the elastic deformation doesn't really do anything to keep the thing put together.
Snap.
Yeah, snap fit joints. Like a cantilever snap fit might have this. Okay, so this thing raises up elastically and then falls back down and holds the thing together. So it's not permanently deformed when it's doing its job of holding the parts together. Mechanical fastening can be accomplished by using interference fits. Which type of fit takes advantage of a material's coefficient of thermal expansion? I wonder.
I hate the word.
An interference fit takes advantage of the material's coefficient of thermal expansion. Is it A, force fit, B, shrink fit, C, running fit, D, all the above? Yes, shrink fit. What type of snap fit is shown below?
What's it look like?
It looks like what I just drew. Well, there is elastic deformation. That does happen. It's not one of the answers, though. Is it A, annular, B, torsion, C, cantilever, B, ball and socket?
Cantilever.
Cantilever.
They spell that.
It's C,
Appreciate it.
cantilever. C-A-N-T-I-L-E-V-E-R.
Appreciate it.
Cantilever. A toy car shown below is assembled using what process? Good answer. Wrong. It is not an annular snap fit.
Little tiny isn't
This is the underside of a Hot Wheels car.
Oh.
it? Little tiny baby.
No. Yeah, snake. All right. Then there's a picture of a Philister head, an oval head, a flat head, fastener. Make sure you know about a pan head. Make sure you know whether a socket head cap screw is actually a screw or whether it's a bolt. This type of cross recess was, don't be fooled, this type of cross recess was originally designed to limit the amount of torque that a tool could put on the fastener. It is a type 1 cross recess. Yes. Identify the pin shown below. Two pins in that picture. The smaller pin is the one that I mean. And it actually says that.
So it says smaller pin.
It's the smaller pin. Cotter pin, yeah. All right. Good guess. This surface finishing process is similar to electroplating in reverse. But then we haven't talked about that, have we? It usually removes a small amount of metal. It's e-polishing, electro-polishing. Supposed to talk about that tonight. This process grows a thin, hard oxide layer on the surface of aluminum. It can be dyed and sealed to produce a colored workpiece. You don't know that offhand? It's anodized. This process grows a thin, hard oxide layer on the surface of titanium. The thickness of the oxide layer determines the color of the finish. That too is anodizing, but it's sort of a different world from anodized aluminum. As maybe we'll see if we do less of that far.